So we need to talk about three different types of things. Let's go from biggest to smallest, shall we? Let's talk about dwarf planets. Okay. Oh, really? So this is everybody's favorite dwarf planet. It's Pluto. Good old Pluto. What do we know about Pluto? It's pretty far out there. Yeah. It's got a moon that is big relative to its size. That is true. Yes. That is true. Let's see here. So when we talk about the, Sharon or Karen or Charon, people use different names for it. Here is a size comparison to the Earth. Pluto has about the same surface area as the country of Russia. Okay. Eris is a little bit larger. Eris is a dwarf planet as well. Makemake, I like to say that this is the dwarf planet so nice they named it twice. Ceres, Haumea, okay, all of these different dwarf planets. There are multiple dwarf planets in our solar system. Ceres looks like it has atmosphere. Yeah, so this is a fuzzy image. All of these are old images. So let's look at Pluto. So this is not a real image. This is. Maybe. Thinking about it. I guess not. There we go. This is a real image of Pluto. Pluto is mostly water ice. It is real cold. It appears to be geologically active. So, the continents of Pluto are made out of ice. Out of water ice. And they move around. Here is a false color image. So this is an image that they have taken the wavelengths and kind of increased their intensity of color. So this might be what Pluto would look like if it was really close to the sun, in terms of just like the lighting. You have to remember that the pictures that we have from Pluto were taken in very dim conditions. Because the sun, all the way out at Pluto, the sun is like a slightly brighter star. Essentially, it looks very similar to some of the brightest stars in our sky, just a little bit brighter. Yeah, it is crazy. It is way out there. Pluto is really far away. Okay. In a place that we can talk about maybe in a bit, called the Kuiper Belt, which we'll discuss. Okay, so that's Pluto. Okay, dwarf planet Pluto. And Charon, or Charon, or I don't know how people pronounce it. This is again, once again, got another real image here. You can see Charon hanging out in the background. Back here. Really interesting thing about Pluto and Charon is how they orbit each other, okay? So for instance, let's talk about the moon, right? So when we talk about the moon, let's do some drawing because I know that everyone's been craving some of my beautiful art skills. Yeah. Come on, computer. Oh boy, where'd it go? Oh, there it is. Okay. So the Earth, let's do the Earth is blue because, oh, Let's change this to the highlighter because it looks better. So here's the Earth. Oh my goodness, I'm lagging out here. So here's the Earth, so beautiful. And the moon orbits the Earth. If this was the correct size, the moon would be like way out here, but remember, nothing is to scale. The moon orbits the Earth, yes? It shouldn't be too controversial. Well, remember when we talked about gravity, about how the gravity pulls equally in both directions? So really what it is the moon and the Earth orbit each other. And the Earth and the sun orbit each other. But the center of gravity, the center of mass of the moon and the Earth is inside the Earth. And it goes around. This is what creates tides. Okay? The center of gravity of these two bodies is inside of the Earth. And it's the same thing with the Earth and the sun, right? The Earth and the sun technically orbit each other, but the sun is so much more massive than the Earth that the center of gravity is inside of the radius of the sun. That is actually not true of Jupiter and the sun. Jupiter makes the sun wobble just a little bit in its orbit. The center of gravity between Jupiter and the sun is actually just barely outside of the sun. So it does a little like wiggle, okay, as Jupiter goes around. What's interesting about Pluto and Charon, and we're going to let's do Pluto as red. So here's Pluto. And we'll do Charon as black. Again, I don't really know the correct way to pronounce that. I believe it's Karen or Sharon or whatever. The center of gravity of this two-body system is like right here. So really what happens is when Charon goes this way, Pluto does a little circle, while Charon does a big circle. Oh, that's a beautiful circle.
That's the most weird.
I know that all orbits are elliptical, Mr. Croshaw, but come on. All right. So Pluto does a small circle, Charon does a big circle, because their shared center of gravity is actually closer to the midpoint of the two than anything else. Okay? Pretty interesting. So that's Pluto for you. Again, it's a dwarf planet. It's still a planet. It's just not a full planet. It's a dwarf planet. Wilkes? Okay.
Michael Brown is coming for that.
Michael Brown. Yeah, remember Michael Brown? He was the guy that said, yeah, Pluto killer. He said Pluto probably shouldn't be considered a planet.
It's going to be a comet.
It's going to be a comet. Yeah. Okay. So that's Pluto for you. Not anything too like fascinating. So a few other dwarf planets in our solar system. There's Haumea, Makemake, Sedna, Orcus, Quaoar. That's Quaoar. I don't remember how to pronounce that. 2002 TX300, 2002 AW 197, Varuna, Ixion, Vesta, Pallas, Hygeia. Okay, these are all different dwarf planets in our solar system. So remember the three criteria points of a planet? Yeah. So it has to orbit the sun or orbit a star, and it has to be semi-spherical, and it has to have cleared its orbit. None of these objects have cleared their orbits. Haumea. So here's what's weird about Haumea. Okay? Haumea has actually achieved hydrostatic equilibrium. It is large enough to be. So all of these are artist renders. We don't have like really high definition pictures of Haumea, but we do know that it is not spherical. What? We do know that it is not spherical. It is extremely oblate. And the reason why that is because it spins real fast. It's a spinny boy, okay? And because it spins so fast, it flattens itself out. Kind of like a pizza dough. Flat Haumea society, yeah. So Haumea spins so rapidly that it has greatly altered its shape. It is more disc-shaped than spherical because of its rapid rate of spin. Again, none of these are actual images. This is the best image that we have of Haumea. And you're like, wow, that's not very impressive. It's true. But you'd be amazed at how much scientists can derive from very, very simple looking images. Okay?
My question is, how from that image they get that it was flat?
That it was flat.
Like, man, it must be spinning pretty fast.
So when we observe Haumea over a long period of time, we see that its light curve shifts greatly. And so it gets bright and then it'll get dim, indicating that it shows us the long side and then the short side alternately. Okay. Yeah, Haumea, pretty interesting. Make said, let's talk about another dwarf planet that is, in my opinion, really important. It is Ceres. These are real images. No, not that one or that one, but this one is. This is a real image of Ceres. Ceres is the queen of the asteroid belt. It is also, fun little fact for you, back in the late 1800s, Ceres was considered a full planet. Ceres killer, yeah. Ceres, we didn't really know what to call Ceres. Eventually we moved it from planet to asteroid, and now we consider it a dwarf planet. Ceres is named after the Roman god of grain. And this is why when you pour yourself some frosted mini wheats in the morning, you call it cereal. Wow. So your cereal is named after the Roman god of grain.
Isn't that like also Hades?
Wife of Hades?
No, different version.
So, yeah, so Styx and Nyx and so Pluto has a bunch of smaller planetoids kind of going around it, and moons that are named after some of the assistants to Hades or Pluto in the Roman gods. Yeah,
Where the spirits of different.
yeah. So this is pretty fascinating. Ceres is the largest quote-unquote asteroid. It's the largest body in the asteroid belt. It is much smaller than the moon, but it is large enough to make itself spherical, and it does orbit the sun, so we consider it a dwarf planet. Yeah?
What if Ceres hit planet Earth?
It would be a bad day. It would be a bad day if Ceres hit Earth. Ceres is primarily metallic. Life would continue, but I would imagine that most things that are bigger than just a couple of cells would go extinct. So life would be set back about 3 billion years in terms of evolution. Be a rough day.
Okay, good start.
It would liquefy most of the Earth. So most of the Earth would become liquid magma. It would be a bad day. Here's a size comparison. Alien life boost, huh?
So
Express. The Express is such a trash news site. Oh my gosh. Don't read the Express. What?
the first one is like, how can something so small compared to the Earth make the entire Earth magma
If it hit it?
Yeah.
Velocity.
You'd be going like really fast. Yeah.
What is the equation for force?
F equals ma.
Mass times acceleration. Yes?
Yeah.
What is the equation for energy?
Energy.
Mass times velocity squared. Hey,
Hey, what's the name of our current epic?
our epic.
Yeah, not the
Um,
Holocene.
so
We were in the Holocene.
we are currently in the Anthropocene.
That's what I thought. Thank you.
You're welcome.
Question mark?
Question mark. Every once in a while, we'll do that. Like I'll go in there and ask her a question, and she'll come in here and ask me a question. What?
So if Ceres changed its orbit for some weird reason, kept its same speed and headed directly to where Earth is going to be, like in a collision path, how long do we have to evacuate into space?
We'd have a couple of years.
So
Meh, we'd have 6 months maybe. If we discovered that Ceres changed its orbit and was on a collision path with the Earth,
It's already.
we would have maybe 6 months.
so if all the governments put all their money in, do you think we could make it to Mars before?
All of us, absolutely no. A few of us, yes.
Yeah.
Humanity would survive because we have a space program and the dinosaurs didn't. Idiots. Okay, so that's Ceres. Okay, those are the dwarf planets that I really wanted to talk about. Ceres, Haumea, Make, Pluto, Charon. So Pluto and Charon are technically considered co-dwarf planets. Co-dwarf planets. Because people want to say Charon is a moon of Pluto. I think that they're more like a binary star system than they are actual like planet moon system. Okay? All right. So that's that. That's what Mike, you've been drinking the Michael Brown Kool-Aid, Mr. Croshaw. Okay. Who wants to watch something explode in the sky?
Ooh, explosion.
Chelyabinsk.
Oh, I remember this.
I know this thing.
This was crazy.
This was crazy. Yeah. Over 1,000 believed injured. Let's do compilation, shall we? Yeah, let's do this one.
Oh, is that the
Meanwhile,
one
in Russia.
Russia.
So yeah, so this is Chelyabinsk, Russia. And spoiler alert, things hit Russia a lot. It's because Russia, it's not because the universe hates Russia, or well, maybe rephrase that. It's not only because the universe hates Russia, it's because Russia is so long and covers such a large radius or such a large angular size of the Earth. So for reference, the sun never sets on Russia. Okay, when it is setting in the western part of Russia, it is rising in the eastern part of Russia.
Dang. So
That sounds
Okay.
like
that's so cool.
That is so.
they should have that as like part of their money. The sun never sets in there.
The sun never sets in Russia. Okay, so in Soviet Russia, the sun sets not on you but on me. Okay, so I don't know what I was saying there, but so this is Chelyabinsk, Russia. And of course, everyone in Russia has dash cams because they drive terribly.
It's like a legal mandate.
Yeah, I'm pretty sure it is. And so most of this video is from dash cams. And I love that these people just keep on driving like nothing's happening. Oh, there's this thing that's brighter than the sun in the sky. Let's just keep on driving.
I'm just imagining like,
and they just keep on going. Like, and in all these videos, I'm not going to play the audio, but no one even says anything.
it's just like,
They're just like, Soviet Russia.
I'm just imagining.
Yes,
distracted
comrade.
By the
Yeah.
That's too loud in there.
They're just constantly playing their national anthem.
Yeah.
I'm surprised they haven't put a thing.
So,
where it's
yeah.
like that song played while this thing's just going.
Can you imagine seeing that? And like, the people just walking by.
It's just like, oh,
It's probably just a missile test.
like, I'm just imagining another miss.
Okay. As they go, they're just walking by. Okay. This is, and we'll talk about the size of this meteor. Okay. So once again, dash cam, driving along. You can see the sun rising. So this is early morning in Chelyabinsk. And here it comes. There it goes. No one even slows down. Like, guys, it's crazy. We're just gonna keep on going. That was actually one of the best angles because they turn right as the, and you can see the glowing embers of the meteor as it cools. So what happened is, we'll go to the next video here.
They have one that's closer.
No, because this happened really high up in the sky.
Well, I mean, closer to where.
Oh, and of course this person's gonna pass. Wow. 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 Dude.
He passed everybody.
What? How long is this video?
I follow.
Okay, so there's the smoke trail. I'm gonna play the audio. For the people watching on YouTube, you're not gonna hear this. This is gonna be loud, just to warn you. So they're looking at the smoke trail, and then here it comes. Maybe. Maybe. No. Not gonna happen. Oh, missed it.
I just like that one person who was speaking to be like,
So it was loud, but not only was it loud, it also did this.
"This is no missile. This is no missile."
Sputnik.
I'm just imagining it was not missile.
So watch this.
All the windows.
So this shattered windows for over, yeah. See all these windows just go boop. Car alarms. This one's pretty good. I love that they set it to metal. So all this stuff starts falling from the ceiling. Window blows in.
Sorry, but that reminds me of the meme where the guy just falls through the ceiling. Oh, hey,
So
Fred.
this is a garage door right here. Boom, just blown in.
Wow.
So this is a shock wave because the energy released by this meteor was more than the power of the atomic bombs dropped on Hiroshima and Nagasaki. The difference is that this exploded much higher up in the atmosphere. So the bombs that were dropped on Hiroshima and Nagasaki detonated relatively close to the surface. I believe about less than a kilometer above the surface of the Earth, which is relatively close. Okay, I think it was like 600 or 500 meters above the surface. They didn't make contact with the surface. The designers of the bombs calculated that would maximize destruction, which is kind of messed up for a lot of reasons, but I'm not going to get into the politics of 1945 and the Second World War. This exploded way up in the atmosphere. We're talking like 60, 70 kilometers up in the atmosphere. So there was much more time and much more space for the energy from the explosion to be dispersed through the atmosphere. So you can see it starts hitting the upper atmosphere, getting really, really hot, and then right there is when it explodes, right there as it gets brightest. And that explosion was about 50 or 60 kilometers up in the atmosphere. Okay? If it had held together for longer, we wouldn't be talking about over 1,000 people injured. We'd be talking about tens of thousands of people dead. Okay?
And then they like go about their life.
yeah, they don't really care.
What would have happened if it?
I mean, if you grew up in a country where you saw a polar bear fighting a grizzly bear, I don't think that you would probably be fazed by too many things. Normal Wednesday. All right. Reapy, did you have your hand up? Who had their hand up? Wilkes. This is an excellent question that you have anticipated what we're going to talk about. So the Chelyabinsk Meteor. Chelyabinsk Meteor. Good old Wikipedias. It hit the atmosphere, so it was about 20 meters across, 66 feet. It hit the atmosphere at 19 kilometers per second, which is about 65,000 kilometers an hour. So remember when we were talking about energy, right? The formula for energy. Energy. Okay. Images. So kinetic energy, half mass times velocity squared. You see this velocity squared situation? When you increase the velocity of something, you increase its kinetic energy by twofold. Well, exponentially, yes. By an exponential relationship. Okay. So this was not a huge meteor. It was only 20 meters across, but it hit the atmosphere at going at 65-ish thousand kilometers per hour.
If it had been going twice as fast.
It had been going twice as fast, then it would have put 4 times as much energy into the atmosphere. Okay, because you square the velocity.
How much faster would it have been going to kill all of humanity?
To kill all of humanity, a significant portion of the speed of light. Because this is just not very big. 20 meters is not very big. Here's the thing, y'all. We cannot see these things coming. Chelyabinsk is what's called a city killer. Okay? The Chelyabinsk meteor, if it had hit directly on a city and if it had lasted just a little bit longer in the atmosphere, it would have wiped out a city like Atlanta or like Lagos, Nigeria, or a city like Nice, France. Okay, these cities would be gone. All right. And this is something that's 20 meters. 20 meters is like the length of this hallway. It's not very big. And that's why it's hard to see these things. Okay? That's why it's hard to see these things. In fact, I would think that the 20 meters would probably be about the length of the carpeted section of this hallway outside my classroom.
So did they get like an advanced warning or something?
Nope. We had no idea that this thing was coming. Okay? No idea.
Also, the Russians were like, you know.
We're constantly trying to protect ourselves from these kinds of events. But the thing is, the solar system is a shooting gallery. There's stuff flying around all over in the solar system. We're trying to find near-Earth asteroids. Let's talk about one more thing here. The Tunguska event. And yes, it's in Russia again. So this was in 1908. Okay, but we didn't know that it happened until, well, we knew that it happened because there were reports, but we didn't really see where it hit until 1927. So let's.
Because Russia was.
No, because it happened in Siberia, and there's just hundreds of thousands of square kilometers of unexplored forest in Siberia. So the Tunguska event knocked down trees. So this is what it looks like today. This is an artist's rendition of what it probably looked like when it happened. And this is the trees that were photographed in 1927. So this is 19 years after it happened. We're talking about, I think it's like 8 square kilometers of trees all flattened. Okay?
And nothing grew back.
Nothing grew back in this area right here.
Why?
Because this area is full of what's called shocked quartz. So the soil has been shocked and compressed by the explosion to where it cannot grow large trees. Okay? Pretty crazy. All right? The Tunguska. This is not it. This is Crater, Arizona. Yes, it's very imaginatively named. Crater, Arizona. So yeah, the Tunguska event. Still no trees. So this was another meteor that hit the Earth. 80 million trees over an area. Oh, excuse me. 2,150 square kilometers. All knocked down. If this had happened over a city, this would have destroyed the city. Again, this is estimates of energy range from 3 to 30 megatons of TNT. An explosion of this magnitude would be capable of destroying a large metropolitan area. Okay, I believe that the Hiroshima bomb was like 6 megatons, something like that. Pretty crazy, okay? Pretty crazy. So that's Tunguska. Who's ready to be terrified? Near Earth asteroids. Here it is. Prepare yourselves. So map of the increased count of all known asteroids in the solar system between January 1st, 1999 and January 31st, 2018. Blue represents near-Earth asteroids, orange, main belt asteroids between the orbits of Mars and Jupiter. So in this animation, oh, that's not what I meant to do. In this animation, can we, okay, you don't need to. So this is all of the asteroids that we knew about in 1999. All right? Now let's see how many more we find. A few more.
This isn't alarming.
So all of these dots are asteroids. Again, this is not to scale, but there's a few of them that we need to keep track of.
There are like a few like planet killers that
Directly
directly headed towards Earth.
headed towards Earth, no. So are there planet killers out there? Absolutely. Absolutely. One of them is Apophis. What? No, that's not what I wanted. Oh, Apophis. So, countdown to Apophis. Asteroid Apophis was discovered in 2004. 2029, Apophis will travel 19,000 miles from the surface of the Earth, 11 times closer to us than our moon. So in 2029, you thought the 2020s were starting off bad.
Ending up with a big bang.
This Apophis will pass between the Earth and the moon, we think. There is a non-zero chance that Apophis could have its trajectory slightly altered in a way that would hit the Earth. A non-zero, meaning that it is above zero, but it is not really high. I believe it's much less than 1%, something like 1% of 1%, so 1/100th of a percent.
That's still a lot.
Yeah, it's still a lot of risk. Yeah.
I'm surprised that that's not a bigger thing, you know, like President saying there is a chance we could
Yeah.
all be there.
Yeah. So I mean, yeah, but that would require responsible leadership. But 2029 will pass by. It will also come back around in 2036. Oh wait, let's look here. Is this Wikipedia? Tell me that this is not. I don't know. This says that there's so it's 370 meters across. It says that there's a 2.7% chance that it would hit the Earth on April 13th, 2029. That's a lot.
Well, it's not that they corrected that change.
They corrected it? Where did it say that?
I think the same text.
Oh, in this? Oh, additional observations provided. Okay, eliminate the possibility. Yeah, yeah. So, but there is a non-zero chance. It's about 340 meters wide, it says, according to NASA. Which, remember, Chelyabinsk was 20 meters. All right? Now we're talking about something that is much bigger. 300 meters. Okay? Pretty crazy. 2029 flyby, Apophis will first become visible to the naked eye in the night sky over the southern hemisphere. Look like a speck of light moving from east to west over Australia. Mid-morning, the U.S. and Apophis is above Australia. Apophis, blah, 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 blah. Closest approach to Earth just before 6 p.m. Eastern Daylight Time, April 13, 2029, will be over the Atlantic Ocean, move so fast that it will cross the Atlantic in just an hour. The asteroid will have crossed the United States by 7 p.m. Eastern Daylight Time. Yeah. So let's also just acknowledge that Apophis is named for the demon serpent who personified evil and chaos in ancient. Why are we doing this? Why do we want this to kill us? Anyway, do you need to be panicking about this? No. Should we have at least a contingency plan if we discover that its orbit has been slightly altered? Yes. Okay. This is an S-type, stony-type asteroid made mostly out of rocks. So it's not a worst-case scenario. I mean, at least that is the case. But
What do you mean it's not a worst case scenario?
it could be metallic.
Oh. Well, I mean, it's a planet killer. What's
Yeah, but I mean, at least it's not like Psyche. Psyche.
Would all people die either way?
I don't know if everyone would die. We have a really good like understanding of how to live in like bunkers and so forth. Humanity would probably survive even if we were not able to get off the planet. Psyche is a pretty much like a worst case. If Psyche was to come toward Earth, it would be a bad day. Psyche is thought to be the remnants, the remaining core of a dead protoplanet, and it is almost completely metal. None of these are real images. This is as good of a definition as we can get. This is Vesta, which is another asteroid. Vesta's another dwarf planet in the asteroid belt.
How can you tell that it has those two big craters?
I think that this is just kind of extrapolation of light curves coming off of the asteroid. Okay, so to finish things up today, what is the difference between an asteroid and a meteor? Okay, I've been kind of using those terms interchangeably. And I want you to understand the difference here. Asteroids are rocks and pieces of metal in space. Meteors are the flash of light as it enters the atmosphere. So when I was talking about the Chelyabinsk Meteor, the meteor is actually the flash of light. It's the thing that you can see. It's what we call a shooting star. Okay? The asteroid that caused the Chelyabinsk Meteor was a chunk of rock and metal that hit the Earth. Okay? A meteorite is the actual thing that you can pick up off of the ground. So I want you to understand that the differences between those three things. Asteroids are things in space, chunks of rock and metal. Meteors are the things that we see as the flashes of light, the streaks of plasma left behind by these things hitting the atmosphere. And a meteorite is the thing that you can pick up off of the ground. Okay? That's going to end the video for today.